So this week we're going to work on 8.3 and we'll have a video today and then a little bit of homework practice and then just practice tomorrow and then quiz on Thursday. It's kind of our plan for the week. And so 8.3 is our hyperbolas, and so with these we will have another set of formulas like we've had for quadratics with parabolas and with our circles and ellipses. And so with that, we will make sure you're organizing your formulas because your test is open notes, and if they're organized it makes it so much easier for that and faster for you since you still have to meet that time requirement even though it's open notes. So with that, let's go ahead and get started with our hyperbolas. And so a hyperbola is going to be the set of all points in a plane whose distance from two fixed points in the plane have a constant difference. And so the fixed points are called foci, which is the same definition for foci that we've been using for parabolas and for ellipses and circles. And so the fixed points of the foci, the line through the foci is called the focal axis. And the point on the focal axis that's midway from the foci is the center, which is how we've used the center for our ellipses and hyperbolas, ellipses and circles, And the points where the hyperbola intersects is the focal axis are the vertices of the hyperbola. And so the vertex is still like we used it in our parabolas, except now there's two instead of just one. So to combine all of this with an imagery, and remember these can go left or right, or it can also go up and down. So first off, just to get a picture to go with all the pieces. Sorry guys, you can see my two vertexes, and I have labeled the focal axis for you as well. And so the vertexes, the center, and both foci are all on the same line, which makes it really nice. And so because this one has a horizontal line, it kind of looks like I have two parabolas going left and right, which means that if I had a vertical focal axis, then my hyperbola would be going up and down if it's all in the opposite direction, and we'll see that in a minute. And we'll talk about how to tell which one's which and all of that once we get our formulas. So, just so you can see how this distance works, so C is still the value that's going to coordinate with my foci, and then we will see how do we calculate C, how do we calculate all these different pieces. But right now you can see that the distance with the foci and a point that's how that difference ends up coming into play. So let's go get all of our formulas and see how this works. So I'm going to set this up like we did the other ones that we've talked about, and I'm going to get my lines drawn. And so with your standard equation, notice now A is going to go with whichever one is positive, which makes a big difference. And so because of that, these sets of formulas look really similar except for the fact as to that top row. And so with that, we're going to stay, this one is, all of these are for when I'm centered at 0, 0. And so obviously that's going to change a little bit when I'm not centered at 0, 0. But for now I am, which we like. Take a moment, hit pause. But so the main direction is lined up with A goes with whoever is the positive value. Okay, so A goes with the positive term that we have. I do think that it's easier to get the formulas just for a general center and not just necessarily with this center at 0, 0. So if you want to hold off and get those all at once in a minute, These are just our abbreviated formulas, including for our two asymptotes, which kind of show you how do I draw these U-shaped curves for my hyperbolas. So I want to point out that the one with the horizontal focal axis is actually going to be the one that has my positive x squared, okay? So that has my horizontal focal axis, and you can see that with the image here. And the one with a vertical, the one with the y-axis being my focal axis, is the one that has the one that goes up and down for the two that are stacked on top of each other. So let's go and use one that's centered, and let's go find our vertices, the foci and vertex and center, all that good stuff. Let's go do an example. So here's an example. Okay, so first to find the vertices and the foci, I am going to go ahead and point out that my center is at 0, 0. And I know that because there's no x minus something squared or y plus something squared. So in this case, first thing we need to do is we need to divide every term by 36. And that's going to be because I need a 1 at the end like I did with my ellipses. So with that, I would have x squared over 4 minus y squared over 9. So because x squared is positive, I will have a horizontal focal axis. Okay, and so that means my foci and my vertices are all going to be this time on the x-axis because my center was 0, 0. So my a value is the square root of the number under x, and my b value is the square root of the number under y. So in this case, I have 2 and 3. So to continue, we need to go and find what c is so I can find what my two foci are. And so c squared equals 2 squared plus 3 squared. So c squared equals 4 plus 9. So c squared equals 15, but c all by itself is the square root of 15. Okay, so the two foci will be I will add and subtract c. So my first foci, or my first focus, would be the square root of 15, 0. And the second one would be negative square root of 15, 0. So it also asked me for my vertices. And so because that's where I'm actually on the hyperbola, I'm not in the in-between, that's going to be the value of a. So a, because I'm going horizontally, would be positive 3, 0, and then at negative 3, 0. Okay, so square root of 15 is bigger than 3 because it's bigger than the square root of 9. And so that is going to be on the outside of those vertices, which we wanted it to be. So I put square root of 15, guys. That's not right. This is 13. I do know how to add. That should be 13 and 13. And then this is a 13 and this is a 13. Okay. So another thing we can do is go through and find the equation if we know its center. This one's still in the section where we're assuming the center is 0, 0. And so using the foci and the conjugate axis, which if you had the formulas, the conjugate axis is kind of like our semi-midpoint, minor axis back for ellipses. And so with this one, so with my foci being at 4 and -4, okay, and notice that because of where they're located, they're changed the 0, 0. So if we're assuming the center is at 0, 0, then my formula, I need to find out which one's x squared and which one's y squared and which one do I have. So I would have a squared minus b squared equals 1. Okay, so the foci go in the direction with a, okay, but notice that it's the y value that changed this time instead of the x, like in the last example that we had when we wrote up my two foci. And so because of that, this one's major direction is going to be y squared, and I'd have x squared for b. And that's because the foci, whichever direction is changing numbers between my two foci points, my two focal points, that's going to be the direction I'm aiming in. So because it's y squared, so that would be y squared over 4 squared, because it's 4 units away from 0 and 4 units away from 0. So then minus x squared over what equals 1. So the entire length is 2, and so b would equal the conjugate measurement divided by 2, because we have to cut it in half. So this time it is 1, so that would be x squared over 1. So that is y squared over 16 equals x squared, not equals, minus x squared over 1 equals 1. And that would be my equation. Okay. I did some stuff wrong, guys. My foci, that's not A. If that was my vertices, that would be A. 4 is equal to C. Okay. So what I have to do, I have to go erase my A, guys. My B is correct. I did A wrong. Okay. So if that's 4, if C is 4, then 4 squared equals A squared plus B squared. Because it's the foci. If that was my vertice, what I did was right. It was not my vertice. So I have 16 equals A squared plus 1 squared. And so 16 minus 1 equals A squared. And so A squared is 15. So A is only the square root of 15, but because I'm replacing all of A squared, I do have just 15 here and 15 here. I'm sorry about that mistake, guys. So let's go actually practice with the formulas we're going to be using with HK. Okay, so these are the ones you should save and use and have set up. So these are the ones that include, hey, the center's not 0, 0. How do we use that? So really everything is the exact same thing, except everywhere there was a 0 earlier, you have H and K. So H and K, H and K, H and K, H, K, K, H. So when X comes first. And so otherwise everything is the exact same. Okay. Along with my slopes down here change. They did on the last one as well. I didn't point it out. So just be careful with that. So let's go and do an example with these, and then I'm going to stop the video for today and let you get to some practice. So here's the images if you like them. I think this version makes it more distracting and it's hard to follow through. If you like them, press pause, because I am going to keep going and just go do an example. Okay. So it does tell me to find the standard form for the hyperbola whose conjugate axis has endpoints of -1 and 4 and 5, 4. So I'm going to do a little sketch so I can help see what's actually happening. So first of all, I'm going to draw my axes in here. So my axes. Hold on. Okay, So I'm going to go put my points on here. So I'm at negative 1, 4. And I'm also at 5, 4. Okay, so this is my semi-conjugate axis. So that means that's my small direction. And so my big direction is going to go up and down right in the middle. Okay, so with that, what's halfway between 5 and negative 1? Well, that's going to be 2. So because of that, the point 2, 4 is the center. Okay, so far that's what I have. And it tells me that my transverse axis has length 8. So if it has length 8, that means I go up 4 units. And I also go down 4 units, and that was not in line together. Okay, so that would be 4 on top and 4 in the bottom. Okay, so it does say the transverse axis, and that is going to be referring to our major axis. And so because of that, it does make it nice and easy for us because we're already kind of set up for success here. So with me going up 4 and down 4, so first of all, I already know what my center is. And so I need to have my y squared, because I am in the direction of y because my major was up and down. Okay, so it'd be y squared over a squared minus x squared over b squared equals 1. Okay, so I know that my b is the distance between my center and too far its other point, and so the difference from 2 to 5 is 3, and the distance in the other direction is also 3. So I know that b's value should be 3. Okay, so now I messed up with the x squared and y squared because we're not centered at 0, 0. So that should be y minus 4. And then I should have x minus 2. I'm making a lot of mistakes, guys. Bear with me. So a's value, these are my vertices. Okay, so because those are my vertices, their measurement length away is 4. So a is 4. So then I'm going to have officially y minus 4 squared over 16 minus x minus 2 squared over 9 equals 1. And that's my standard form for my equation. Okay, so with that, let's also go through and talk about how do we find... Oh, there we go. There's the final image as well if you wanted it with the 2 different pieces. So let's talk about how finding the center, the vertices, and the foci of the hyperbola when it's in this format, and then we are good to go. So first off, the center is definitely the easy part. So the center is the opposite of what comes with x and the opposite of what comes with y. So in this case, that is my center. Okay, so the vertices are the next part that's really easy. So I'm going to go ahead and identify A is 2 and B is 3. It's because we're going to need C. C is going to be the square root of A squared plus B squared. And so because I'm not going to add this wrong twice, 4 plus 9 is the square root of 13. Okay. So to find the vertices, I'm going to add them in the direction of So x is the main variable, so I'm going to add them to x. And so my vertices, I would add a to x. So I would have -1 plus 2, and then I'll keep my y value. And then I would also have -1 minus 2 and keep the y value. So that's going to be 1, 0, and that's going to be -3, 0. Okay, so last but not least for my foci, I would have same thing. I'd have -1 plus or minus the square root of 13. So that's gonna, and then I have a 0. So that's going to depend on the direction of the problem in your homework and what version of that you're going to need to use. So be careful with it. But that's our video for today. It'll be a short homework assignment today and a little bit longer one tomorrow. And then just quiz come Thursday. Love you guys. I miss you. I'm trying to talk some of you to come into my office hours, so if you want to see my new puppy, come to office hours on Wednesdays, and you can meet there. I'll talk to you later. Bye.